for this problem. What we have is tan squared equals 3x, tan squared of 3x equals 3. Now, while, Chris, yes, we could use our Pythagorean identities to transform tangent, we don't have to, in this case, to simplify the expression. Usually when we want to apply our trigonometric identities, that's to simplify it, right? Or to get it into a product that we can use. But in this case, we just already have the tangent isolated. All we need to do is get rid of that square. So to do that, we can take the square root. Now remember, when introducing the square root, you have to include the positive and the negative solution. We did that in Chapter 2. We did that in Chapter 3. It's coming back again. We have to make sure we introduce that. So therefore, I have tangent of 3x equals plus or minus the square root of 3. OK? Someone just let her in. That'd be great. So now, tangent gets a little bit more difficult on which point that is. Because remember, the tangent of theta equals y over x. So sine is very easy to see. It's just the y coordinate. Cosine is very easy to see. It's just the x coordinate. But tangent is the ratio of the y coordinate over the x coordinate. So it's not as apparent. So we're not looking for a point of square root of 3. We're looking for a ratio of the points that are going to equal the square root of 3. So if this point is square root of 3 comma 1/2, square root of 2 over 2 comma square root of 2 over 2, and this one's 1/2 comma square root of 3 over 2. So as we're looking for these points, we need to determine, well, which ratio is going to give me the square root of 3. Well, we know that if I take my y coordinate and my x coordinate here, those are the exact same fractions. So that's just going to divide to 1. So that's not going to work. To simplify this problem, I will just use, what about if I say, why don't I take this y coordinate and that x coordinate? That means it's square root of 3 square root of 3 over 2 divided by 1/2. Now you can divide out the 2's, or if you multiply by the reciprocal, you can see that any number multiplied by reciprocal is 1. 2's divide to 1, and you're just left with the square root of 3. Okay, so very easily I was able to determine that, hey, that's going to be my point. So it's that angle, which if you know on your unit circle, that is the angle of pi over 3. So I can just forget about the other angles. All right, and now what I'm going to have to do is, all right, so that's for the positive square root of 3. But what are all the solutions between 0 and 2 pi? So to do that, I complete my unit circle. So now I have my unit circle completed. I say, all right, well, where is this other point where the x coordinate's 1/2 and the y coordinate's the square root of 3 over 2? OK? Do you have a pen that works? Yeah. OK. So, and it doesn't matter if it's positive or it's negative for the ratio. Well, if I reflect over the x-axis, that angle is negative 1/2 comma square root of 3 over 2. That angle is 2 pi over 3. If I reflect that over the x-axis, I get this point, which is negative 1/2 comma negative square root of 3 over 2. If that's 1/3, 2/3, 3/3, that angle is going to be 4 pi over 3. Then, if I reflect that over the y-axis, I get this point, which is positive 1/2 comma negative square root of 3 over 2. And that is, if that's 4/3, then that's going to be 5/3, right? Because all the way around would be 6 pi over 3. So that angle is 5 pi over 3. So therefore, ladies and gentlemen, our solutions so far between 0 and 2 pi are going to be 3x equals pi over 3. 3x equals 2 pi over 3. 3x equals 4 pi over 3. And 3x equals 5 pi over 3. All right, so forget about the multiple angles. We don't do anything with that until the very end. Then what I can do is now just, if I want to just define, well, actually, before I get to this point, I'm actually kind of jumping ahead. Let's find all the solutions. If here's pi over 3, what you guys notice to get to the next solution, I have to add another pi over 3. But if I add another pi over 3 to that, that takes me to 3 pi over 3, which is not a solution, correct? You guys see that? So therefore, if I have pi over 3, to get to my next solution, I would have to add pi, which would take care of my solution 4 pi over 3. And then if I added pi again, that would take me to pi over 3. So if I'm going to find all the solutions, let's find all the solutions first. Then that would be 3x equals pi over 3 plus pi n. Because all I need to do to get to the next solution is add pi. And then I can just keep on adding pi, and it's going to take care of both of those solutions. Unlike the last example where we had to add 2 pi, here we can just add pi because we have 2 of those solutions. And then I can also say 3x equals 2 pi over 3. And again, if here's my first solution, instead of having to go add 2 pi to this one, add 2 pi to this one, if I just add pi, that takes me to 5 pi over 3. So I'll just add pi n to this one. Now I divide by 3. And I could say x equals pi over 9 plus pi over 3n. Divide by 3, divide by 3. X equals 2 pi over 9 plus pi over 3n. OK? Now, kind of forgetting about this here. If I wanted to determine all, so that is all of the solutions. If I wanted to determine all the solutions that are just between 0 and 2 pi, what I'd have to do now is just plug in numbers in for n. So that's all the solutions. But what if I wanted to find just the solutions between 0 and 2 pi? Well, we already know x can equal pi over 9. And we know x can equal 2 pi over 9. But what if n was 1? Then I'd have to add pi over 3. Yes? Yes? I'd have to add pi over 3. So pi over 9 plus pi over 3, well, you'd have to get common denominators. That's going to be 4 pi over 9. Is 4 pi over 9 still a solution between 0 and 2 pi? Yes. If I added, if n was 1 here, if I added 2 pi over 9 plus pi over 3 when n is 1, then again, you can multiply. So that would be 5 pi over 9. 3, yep, 5 pi over 9. No, hold on a second. That's going to be multiplied by 3. Yeah, that's 4. So 5 pi over 9. Now, so that's when n equals 1. What about if n equals 2? N equals 2, now you'd have pi over 9 plus 2 pi over 3. Again, get common denominators. So you'd multiply by 3 over 3 on top and bottom. So that becomes 6. So now it's 7 pi over 9. That still works. Here, if pi equaled 2, then you'd be 2 pi over 3. Multiply to get common denominators. So that'd be 6. So that'd be 8 pi over 9. All right. And again, we can just continue this all the way up until 18 pi. Yes?
If this is 0 to 2 pi, why wouldn't it just be those 4 points that are positive and
Because remember, our angle is not just a regular angle. If we're just solving for our angle x, then yes, you're correct. And for a regular angle x, you're correct. But since I now introduce the tangent of 3x, think about the graph. What does that 3 do to the graph? The 3 changes the period. When before, just real quick, if you guys look at the tangent graph, when tangent of x, remember it goes to pi halves to negative pi halves, right? And it looks something like that. So we're not going to worry. We're just going from 0 to 2 pi, so let's forget about that. And then you have, so it'd be 0 pi halves. That's at pi. 3 pi halves, right? And then you go to 2 pi, right? And then the graph looks something like that. And then it continues, OK? Now, that's what the graph looks like at that's tangent of x. But what about if I do tangent of 3x? Well, tan of 3x, so right now the period of that is just pi, right? The distance it takes for the graph to repeat itself is pi. But now if I do tangent of 3x, now my period is pi over 3. OK, so now instead of it going 1/2, now everything's going to be like at 1/6 because you're divided in. So now the graph is much more shrunk. There's much more of these graphs that are now contained between 0 and 2 pi. Therefore, there's going to be more solutions. I'm going to cut this short because I don't want to keep on going over. You guys can see there's a lot more solutions to this. Again, the question only asked you guys to do these, so that's fine. But I wanted to at least introduce you guys when you want to find all the solutions, you just keep on adding in numbers in for n until you get up to where you can't compute more than between 0 and 2 pi. Now notice between 0 and 2 pi is going to be 18 pi over 9. So I'm just going to keep on adding numbers. The next number I'd add in would be 3. And I'd put 3 in for n. So 3 times pi over 3 is 3 pi over 3. Multiply, get common denominator. So that's going to be 9. That'd be 9 pi over 9, which would be 10 pi over 9, which would be another solution. And then you just keep on going up from there. Yes?
How far can you go up when you have 2 pi over
Same way. Just the constraint, whatever the constraint is. The constraint so far that we've been dealing with, here's no constraint, but when the constraint's between 0 and 2 pi, you have to keep your answers between 0 and 2 pi. So you'd add 2n if you can until you get to 0, 2 pi. But obviously 2 pi, if you're adding 2 pi with no multiple angles, you're not going to have any additional answers because 2 pi is already your domain, right? Or you're within your constraint. 5, 7, so it looks like I'm just going to go off on a limb. That would be 10 pi over 9, 11 pi over 9, 13 pi over 9, 14 pi over 9, 16 pi over 9, 17 pi over 9. And then obviously the next one would be 19 pi over 9. But 19 pi over 9 is not within the constraint. So that'd be it. But anyways, that's the answer I was asking for, at least on that homework problem. But you guys should